Now usually when we want to find the ratio of two powers, we will just say P2 divided by P1, right? So this is called the ratio of two powers. But if you want to find the ratio of two powers, there's an easier way of doing it, which is actually to log it in front. So why do you want to log it? I give you an example why is it useful. Now let's say there's an amplifier here, and the amplification factor is 5 times. And let's say the power input is P1. What will happen is your output will be 5P1, right? Agree? And then let's say it passes through another cable where it suffers attenuation, that means signal power losses. And here we say, let's say the attenuation is 2 times. So what will happen is when it comes out, it will be 5P1 over 2, right? Agree? So you'll notice that every time when we have an amplifier, you must multiply. Whenever we have a cable, we have to divide. But if you think about it, if I were to log it, that means to log the whole thing. Let's say I find log 5 times P1 over 2, wouldn't I end up with log 5 plus log P1 minus log 2? So by finding the ratio using log, I will convert from times and divide into plus and minus. So that's the reason why people find the ratio of two powers, but they log it. So the only advantage of finding the log is that instead of multiplying and dividing, you will plus and minus. So let's say you got 10 amplifiers. So you don't have to times 10 times, but you just have to times 10. That means instead of like your 5 to the power of 10, now it's just 10 times 5. So it's easier to calculate that way. So the reason why we log is to make it easier to calculate. So this log of two powers, ratio of two powers, is just called number of bells. But the number of bells is still not convenient enough, so they times 10 in front. So when they times 10 in front, they call it number of decibels. So what is the advantage of using number of decibels? It's just that when you times 10 in front, the number becomes more like a round number rather than also many decimal places, just to reduce the decimal places. So what is number of decibels? Just a ratio of two powers. That's it. Understand? So instead of just dividing two powers, now we log it and times 10. That's called number of decibels. Now, number of decibels, when you use this formula, so this is your first formula that you need to know. How you use it, you can use in any situation. As long as you put the bigger number on top, that means the bigger power on top and the smaller power at the bottom. Let me give you an example. Now, let's say we want to use it for an amplifier. So there are a few examples we can talk about. Let's say for amplifiers. Now, which is bigger, the power input or the power output? So therefore, when you put the number of decibels, equals to 10 log P2 over P1, the P2 will be your bigger power, which is your P out. And your P1 will be the smaller number, which is your PE. What about for attenuation? If we're talking about attenuation, cable here, power input and power output. Which is bigger, power input or power output? Power input is bigger. Alright, so now we will put the power input on top and power output at the bottom. So put the bigger power on top, smaller power at the bottom. We can also use it for ratio of any two powers. For example, sometimes they will tell you that in a cable, you have your signal and you have your noise. So if let's say we know the signal is bigger than the noise and they want to find the ratio of the signal over the noise, also can use back the same formula. As long as you put the bigger one on top, so if your signal is bigger, you put your signal on top, the noise smaller, you put the noise smaller at the bottom, then you will get the number of decibels that the signal is higher than the noise. So you can use it for ratio of any two powers. Do you understand that? not necessarily only for amplifiers and for cables. Any 2 powers, you can find the ratio of 2 powers using number of decibels, okay? Then there's another term called attenuation per unit length. Now, in every type of cable, for example, we have learned about 3 types of cables, right? We learned about the wire pair, the coaxial cable, and the optic fiber. In each of them, there is a rating called attenuation per unit length. That means how much will the power drop per unit length, which is usually expressed by the quantity number of dB in per kilometers. Okay, they will tell you the number of dB per kilometer. So we call this attenuation per unit length. That means how much your power will drop for every kilometers. So for this cable, or for every cable that you use, they will tell you this rating. So they'll tell you in terms of dB per kilometer. Understand? How many dB per kilometer? So the formula, if we want to talk about the formula will be 1 over L 10 log P2 over P1. So this is the second formula that you need to learn. So if they give you the attenuation per unit length, or they give you number of dB per kilometer, it is actually equals to this formula. So what do we do? Since we're talking about attenuation, which power is bigger, input or output? Input. So we put the input on top, the output at the bottom, and the distance L. Then we have the attenuation per unit length. Okay now. So when do we use this formula? Whenever the question asks you to find distance, then we use this formula. Or the question requires you to use the distance involved, then we use this formula. When they're just finding the ratio of 2 powers without any distance, then we use our previous formula without that 1 over L. Do you understand? Okay, very easy one.